Hi everyone. I'm going to try to just create small little videos so that you can break our lectures apart. Hopefully that'll actually be easier for you than sitting in the classroom for an hour to 2 hours at a time and trying to pay attention for that long piece of time. This way it allows you the flexibility to create or do as much or as little as you want to at one time. We left off before classes ended in chapter 6. We had done sections 1 and 2, which was on the unit circle. I will be bringing some of that back to remind you of everything. And we're going to start in section 6.3. I'm going to title this one Part 1 because I'm going to break it up into pieces to make it easier. And we're going to be looking at graphing those sines and cosines functions of the sine and cosine function. Please ignore the dings and everything. Emails keep popping into my computer quite often, so you will hear that from time to time as students and everybody else communicates. So, sorry. We're going to take the sine function first. I'm going to look at y is equal to the sine of t. I want to remind us that our domain for this function is all real numbers, so negative infinity to infinity, because we can continuously go around and around and around the circle in both directions. T represents the angle that we are calculating. We're going to be taking the sine of some angle and getting a value out, so we're looking at that ratio of the opposite side to the hypotenuse. The range that comes out of just the sine function before we start shifting it and stretching it and smushing it is from -1 to 1, because our hypotenuse is the longest side. So that ratio will always be that opposite side divided by the longest side, so we cannot get bigger than 1. Okay, I am going to throw the unit circle on here. Kind of little here, but just to help me draw my sine curve so we can get a general idea of what the sine curve looks like. Remembering some of the points on the unit circle, remembering that means we have a radius of 1. So this was the point 1, 0. This is the point 0, 1. This is the point -1, 0. Down here we're at 0, -1. Thinking of our 30 and our 45 and our 60s, or our pi over 6, pi over 4, pi over 3, and we will be doing things in terms of radians. I will make the connections again just to help strengthen that for us. This point here is going to be that. Now my brain wants to shut down today. Not the day for it to happen. So, okay, square root of 2 over 2, square root of 2, that's my 45. This is going to be square root of 3 over 2, 1/2. And this is going to be the point 1/2 square root of 3 over 2. And then around. And then these numbers kind of reflect with positives and negatives as we go around. So also remembering in the unit circle only, that we can think of a point as being our cosine and our sine. So I'm going to be kind of plotting these y values as we move around the circle. Okay? So here is my curve. This is going to represent t, so the angles. These are my y values. So when I'm at an angle of 0, my sine function is 0. As I move to pi over 6, I would get that 1/2. As I move to pi over 4, I would get that square root of 2 over 2. As I move to pi over 6, I'd get that square root of 3 over 2. When I hit pi over 2, which is my 90 degrees, I would be up at 1, which is the largest I'm going to get. As I start down this side, I'm going to be going back down these values. And when I get to pi, I'd be back at 0. So there's my sine curve. So it's going to look nice and symmetric, and it's not going to look pretty because I'm not good at graphing. So I'll move my pi. And then when I go into this curve, then my y values are negative. So they're going to go through these values again in the negative direction. When I hit this guy down here, this is 180 degrees. I'm at 3 pi over 2. It's going to be at -1. And then we're going to come back up and hit 0 at my 2 pi, or my 360. 270 degrees here. And then it'll start all over again. And it'll continue to go up and down and up and down. It also goes in this direction because we could go negative directions. So it does continue on and on in both directions. So here would be that negative pi over 2, a negative pi, a negative 3 pi over 2, and a negative 2 pi. And it continues and cycles around and around and around. Some terminology to talk about. When we have these curves that go through these cycles and repeat themselves, we talk about something called the period. The period is the length it takes for a curve to repeat. Now these are my words, not a book's words, so hopefully that makes a little bit more sense. So the period for the sine curve, you'll notice we started at 0 and we went through this whole cycle and we started to repeat ourselves after 2 pi units. So the period for our sine curve is going to be 2 pi. Okay. The other piece that we talk about in the sine and cosine curve is something called the amplitude. And this does have some applications out there, namely frequency of waves, frequency of like your sound waves, pitches, and things of that nature. That's a physics topic. Feel free to talk to Mike Ladock on those. But the amplitude is basically the distance it comes up or down. So this is considered your amplitude. Amplitude. So the amplitude for the sine curve is 1. Okay, hopefully that makes sense. So there is our basic sine curve. Starts at 0, 0, goes up to 1, back to 0, down to -1, back to 0, and then repeats itself over and over and over. I'm going to draw the basic cosine curve next. Again, I'm going to be using my little circle, remembering the cosine is now on this inside part. So we're going to do y is equal to the cosine of t again. We will find that this guy does repeat itself as well as we go around and around. Cosine is going to start at 0 up at 1. Then as we move around the circle, our cosine curves, cosine values get smaller, and by the time we hit pi over 2, we're down at 0. So it's going to kind of smooth and go down to 0. Then we're going to be on this side, and notice our x values over here are negative, and so we're going to go from 0 down to a -1. Going a little faster this time. So when we hit pi, we're going to be down at -1. And then we'll start coming back up. This point here was 0, -1, so our cosine is 0 at 3 pi over 2. Whoops, I missed a little bit. And then it'll come back up to 1. So when we hit 2 pi. And then it will continue to go on in both directions. So here is my negative pi over 2, a negative pi, negative 3 pi over 2, and so on and so forth. Okay, so again, this one looks very similar to the sine curve, just looks like it's moved over a little bit, and in fact they are shifts, vertical, horizontal shifts of each other, but they do have some similarities. The similarities are they do share the same period. So the period for that cosine curve is also 2 pi, because that's how long it takes us until we start to repeat. And we do have an amplitude of 1. So the distance from kind of like the center of that curve. So how high up or far down do we go? So our amplitude in absolute value. Okay. Now what we're going to do is start shifting this guy. So kind of remembering how shifts work. So we're going to look at, just kind of jump right in and look at this y equal to 3, and we'll do a sine curve of 2t. All right, this 3 on the outside, if you can remember, because we have talked about shifts, this is going to affect how things work on the vertical scale. So this is going to stretch the curve vertically by 3. So a way we like to think of it in terms of sine curves is it's going to change that amplitude. So it's going to change our amplitude to 3. The 2 on the inside, and we didn't spend as much time on this one, but the 2 on the inside is going to stretch or shrink, and this one kind of works backwards when you're inside, so this is going to shrink horizontally. So it's going to smush it inward, so this is going to be smushed this way. So that is going to be changing the period. Okay. In fact, if we have just a general curve, let's just kind of throw one in here. I don't know what letters our book uses. I guess they use K. We use a K as well. They use a little a, I put a capital A. A is going to represent that amplitude, if we actually take it in absolute values. And the period of this curve that we have is going to be affected by that k. So we're going to take that old period of the normal period of our sine curve, which is 2 pi, and we're going to kind of go backwards. Instead of multiplying, we will divide it by k. So in our problem up here, our period will become that 2 pi divided by the 2, which is pi. This means we are going to go through one complete cycle in pi units. So it's just going to move everything in. All right, let's draw this guy. So again, we are drawing y equal to 3 sine of 2t. Okay, so sine curve is the one that starts here. It goes up and down and up. That's not going to change because we do just have a positive value. I'll throw a negative value in later. So that means we're going to still have that up, down, and continuing on and on and on in both directions. However, instead of going up to 1 and down to negative 1, that's going to be changed by this 3. So we will be going up to 3 and down to negative 3. This 2 is changing our period, where before we would complete a cycle in 2 pi units, we actually complete that cycle in pi units. So I went from 0 to pi and got that one complete cycle. If I wanted to know where that second cycle ended, we could add pi onto pi, so pi plus pi, which is 2 pi. Another way to think of this is in our normal cycle, normal period, we have 2 pi. We now see 1, 2 curves. So that 2 does reflect to how many curves can you get in the normal period that we used to have. So there is part of it. I always like to have students include these, what I like to think of as the key points, those zeros, and where those highs and lows happen, To do that, again, thinking of how nice and symmetric this curve was, we went through one complete cycle in pi, so that means this is going to happen halfway there. So half of 0 to pi, that would be pi over 2, simply taking pi divided by 2. To get this point, it's halfway between pi 0 and pi over 2, which is pi over 4. Again, I took pi over 2 and multiplied by half. To find the difference between pi over 2 and pi halfway there, you can add these two together and then multiply by a half. So this is like 2 pi over 2. So that's 3 pi over 2 times a half. So that's 3 pi over 4. We also can see counting going on. So here's pi over 4. This is 2 pi over 4 reduced to pi over 2. 3 pi over 4. 4 pi over 4. This would be 5 pi over 4. This would be 6 pi over 4, which is 3 pi over 2. 7 pi over 4, and there's my 8 pi over 4. So we do have that counting that we've seen before happening here as well. Okay, I'm going to do one more before I stop this video, and then I'll come back and do some more similar to this and so forth, but I wanted to do we'll do a cosine curve this time, and I will put a negative in front, and we'll do a cosine of, let's do t over 4, and this time, just for fun, we will also add 1 on the end. So hopefully that makes it more exciting. Yay! Just kidding. All right, so here we go. This guy is going to change our amplitude. Change the amplitude. So instead of going up and down to 1 and negative 1, we will go up and down to 2. The negative is going to affect where we start. So the cosine usually starts up at a positive 1. This is going to make us start down at that negative 2. So taking that positive 1 times the negative 2. This is going to change our period. Okay, so in other words, our old period was a 2 pi. We are going to divide that by the number in front, which is actually a 1/4. So we're taking 2 pi times 4 over 1. So it's going to take us 8 pi in order to get our entire curve. And this at the end is going to shift everything up. Shift up by 1. I will do that last. And so my curve is going to be a little messy, but that's how it works when I'm doing it this way. I can't erase and remake, so we're going to just create the first one in a dotted form, and then I'll shift it up and make it solid. Okay, so cosine curve. So we're going to be going up and down to negative 2 and 2, so I'm going to put those guys in there. And cosine curve is the one that usually started up at 1 and then went down and up. This one is going to start at my negative 2 because of the negative, and it's not going to go down, it's going to go up first and then come back down and go up and down and so on and so forth. Okay, so I can continue in both directions. Okay, oops, I was going to make that dotted. Whoops. Our period is 8 pi, which means we went through this cycle in 8 pi. So we went through one complete cycle by 8 pi. Again, I like to put those highs and lows. So there's my high point. It's going to be halfway between 0 and 8 pi. So divide 8 pi by 2. So that gives me 4 pi. Halfway between 0 and 4 pi is 2 pi. Notice we have 1/4 of our curve in that normal 2 pi period. So going the whole route, we get 8 pi is our new period, 1/4 of it in the old. Halfway between 4 pi and 8 pi is 6 pi. And I could continue my counting: 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, 12 pi, 14 pi, and there's 16 pi, which is 2 of those. And now I need to shift it up. So this point is going to go up here, this point is going to come up, and this is going to look really, really ugly, but I'm hoping you guys can understand it. And I know you guys are pretty darn bright. Whoops, that should be, I can't make my stars very good. But I am sketching, right? Sketch. So there we go. All right, I hope this helps. We will make this work. If you have any questions, of course, please, please, please drop me an email. Look at it through WebAssign, work on those problems. I will be creating a bunch of these videos, little short ones, so that it isn't too overwhelming at one time. So I will talk to you guys all later. I hope everyone's healthy and everything. So yeah, thank you. All right, here we go. Did it a long time ago. It's been there forever.